Uh, Good morning, everybody. I'm going to try to make this timely so we can all go to lunch. I'm really happy to be back at DeepSec. I think this is my 5th year here, so it's really nice. Um, it's great. I like this conference. It's great. So before we start, um, notice the pink lettering at the bottom. What I'm going to show you today, I didn't use to make any money, right? Not one Bitcoin. I've never used this research to do anything but test. I've never released it. I've never, typical disclaimer, I haven't done anything for profit on this at any time. So, who am I? So those who don't know me, the first picture was me a number of years ago when I was still healthy. The middle picture is my avatar. It's actual real picture, and yes, that is a nice big fat Churchill cigar. If you want to get on my good graces, that's the one way to get on my good graces. The last picture is me nowadays, contemplating life, the universe, and everything. I know the answer is not 42. So my day job, I'm a security researcher, an advocate. I go around talking to companies, talking at presentations about data protection specifically. I've been doing a lot of GDPR lately, so this is a good change. But I'm one of the directors of B-Sides London, and I'm a UK ISSA chapter board member. So last year, we saw a massive explosion in ransomware. Some call it the ransomware peak. If you think the Gartner, curve of adoption, we peaked last year on ransomware. There was, So this led me to explore and research because I was getting a lot of questions about it. I was getting how are we going to handle ransomware, and then I was getting the PR guys going, oh, can you give us some ransomware statements and blogs and all that. I was like, oh, okay, yeah, I'll do it, because marketing. And essentially, it boiled down to one of the best ways that I know how to learn something is to actually try it for yourself and break it down and understand it. But as I said before, this never really left the contained environment that I set up for it. And, I didn't say send the ransomware to other people. I said, send nudes. Before I try to introduce some humor before we go lunch. As I said, 2016, biggest ransomware. These are some of the press clippings. And what was really interesting is towards the latter part of the year, we started to see ransomware as a service. So the Russian dark web was starting to launch services where you could actually buy ransomware time for a few Bitcoin. Well, let me rephrase that. You would share the profits on that ransomware. Essentially what the guys were doing is they were building these variants of ransomware and giving you the ransomware so that you could put it into your own back-end, bots and delivery mechanisms. And the thing is that when you get all this press and you have a marketing guys behind you, and then sales guys that are bugging the crap out of you, it's like, how do we demo this shit? Sorry, I forgot to disclaimer too. There's going to be swear words because swear words. You end up getting a lot of pressure, and for like 2 months, everybody's going, well, we can't demo this stuff. We can't demo our solution because it's too hard to use the malware to use the malware lab, and it doesn't really work when we're in front of a customer. So, the simple solution is you build them something. So, let's go back to 2016. Why is it so 2016? Why was 2016 so important, and why I did this? Well, so this graph is from Proofpoint, and you'll find similar graphs from other vendors. It was probably the largest increase in ransomware variants that we've seen to date. Okay, if you look at the beginning of the year, well, at the end of 2015, there was probably like 15 or 20 variants. By the end of 2016, we were up to hundreds of variants. And what was the other interesting part is the primary delivery mechanism was JavaScript attachments or Word, Office document attachments. The orange curve at the bottom is URL drive-by or a malicious URL in an email. People are not really clicking on URLs anymore, apparently, but they are opening attachments. So it makes you think, what are we doing? So, this is one vendor So in my spare time, I actually run an email honeypot. So I was getting all these emails as well, so I could see these variants and these new and the attachments were coming in. So I don't know if you guys know Xavier Martin. So he graciously gave me this data. He also runs a email honeypot, and he's a little bit better than me because he actually runs stats on the emails that come in. I'm just too lazy. I do the bare minimum when I have to, and that's fundamental focus of this of how the next steps that we're going to go into later. So the stats he produced to me. This is 2016. So what you'll notice here is that we actually have a regularity in campaigns, right? So depending on the campaign, you see more or less emails coming in, but you see that there's a peak on a regular basis. If we drill down into a month, you're actually seeing that the campaigns happen at the beginning of a week. So if you take at this, right? So this starts. It starts on Sunday, but you see towards Monday, Tuesday, we have peak. So this was actually an anomaly. We also had a second peak during the week. But take the following week, again, right after Sunday, we see it spiking, and we carry on down the road. So what this was telling me, now, I see this, it continues today as well. You see this on a regular basis. So these guys are sending out campaigns, but they seem to be timing them, graciously timing them so that they appear on Monday, so that they have the week for it to deploy and get sunk in and users clicking on it. And finally, the campaign weeds down, you wait a few days and another campaign. This is like SaaS or DevOps, right? You've got a regular schedule of new varieties coming out. You've got a regular schedule of emails being launched. It's almost like a real IT operations, right? I used to do sysadmin, and we'd introduce new software at the beginning of the week and weed out the bugs over the rest of the days. What was really interesting is that the majority of emails contained zip attachments, and in those zips you either had Word documents or JavaScript. You sometimes have Word documents and you sometimes have Excel documents, right? But it's that compression part that was interesting, because by using that compression part, it just forced the user even more to open or to download that attachment. Now, if we take a look at ransomware, let's just dive into. I'm going to go a little bit more into detail of what a ransomware is. So these are the different variants. F-Secure mapped them out last year, so they did a fishbone. But back to, if you look at up until 2016, we had very few variants, right? It was very simple. Then we get to 2016, and you see January, February, just the number of variants keeps increasing. I think it was June that we had the most variations in ransomware. So that's where we come back to that 2016 being the peak of ransomware. There's a lot less variants this year, apparently, and so far tracked. That doesn't mean it won't change once we get the final count. But I think the big problem with 2017 is because of what happened at the beginning of the year and some of the lethal variants that were coming out. Well, some of the lethal exploits were being used to actually drop ransomware. I think people started to back off a bit. I still see regular campaigns though. And one of the things that was interesting was when you break down these ransomwares, there's 4 fundamental types of the actual ransomware. I'm not talking about the dropper, I'm not talking about the exploit, I'm just talking about the part that encrypts the files. The first one is actually based on scripting languages. So you take a mathematical principle on encryption and you put it into a script. We've seen PowerShell, we've seen batch files using 7-zip, and we've seen Python and PHP. Simple, really simple. One of the good things with this is that because you're using built-in tools, or because you're using tools that are essentially whitelisted by most anti-malware vendors, it is effective. But it's easy to decrypt. Then you see ransomware that's based on a hashing method. So you might have base 64 hashes or RC4s or SHA-1s. You know, we're all in this industry. We know that most of these have been broken or they're just weak, so it's easy to reverse at a certain time. And when you see the guys, you know, some of the companies that say, oh, we've got decryptor for this ransomware, we've got decryptor for that ransomware, it's usually because it's based on one of these two fundamental principles. So the key is actually easy to find, or the method is actually easy to find. The most common one is actually based on a symmetric key encryption. And there we find primarily AES. We saw a couple of variants with GOST. Does everybody know what GOST is? So GOST is a Russian encryption method. It's the only legal encryption method in Russia. And it was built by the Russian intelligence service. So you know all those backdoor problems that we keep talking about in the Western world? They don't have them. DES and triple DES is pretty common too. ROT13 was very common, and XOR was very common as well. Finally, the more complex one, and the one you see it, but you see it rarely, is public key encryption, right? RSA. The problem with public key encryption is if you're going to do that, you actually need to set up a system where you're going to register your keys and distribute public keys to or generate a key pair at the endpoint, securely upload the private key to your storage environment, and encrypt with your public key. It's very complex, so it's a lot harder to implement. Ransomwares. Sorry, I think I'm missing a slide for some reason. I hate it when that happens. So the stages of ransomware, right? If you think about how a ransomware gets onto your system, you have essentially 5 major steps. You've got the delivery method, so how you're going to get it to that victim. An execution method, so some way to get from the delivery and spread the encryption tool or the encryption algorithm, the actual encryption of the files. Then you'll have a spread because you want to actually ensure that you get as maximum deployment, and then you have a ransom note. The thing, spread is really, you only really see if the ransomware uses some kind of exploit. But most of the time, what you're seeing is delivery, execute, encrypt, and a ransom note. So what I focused on really was to be able to build this demo and this testing solution. I basically just focused on the first 3 steps, because that's all you really need to effectively encrypt somebody's files. So if we look at getting our hands dirty, well, it's software development, right? You take some math, you put some code, and you've got software development. But for what I wanted to do this quick and dirty, you know, it's like I don't think malicious parties are actually using this kind of software development methodology. So I looked at it, breaking it down into a little bit more sensible portions and using a mind map. So this is the mind map that I started with. It's a lot more complex now, but this was what I started with. So this is my node, my badass node. So I start with looking at, well, so what do we need? We need a delivery method, right? Well, we've got web drive-by. I don't want to do that. We've got an email. We can put some JavaScript in a zip, or have a Word attachment in a zip, or we can just go with a Word attachment or Excel attachment. Then you need to think about your encryptor. So first you're going to say, oh, how am I going to program this? Well, PHP, PowerShell, C hash, Python, C++. You know, take your pick. C hash and C++ means you need to go a little bit deeper into programming, and why break your brain cells when you can do it very simply. So then you get to actually your code. Then you have to select your encryption method. So you know, AES, ROT13, XOR, whatever you decide to do. Then you got your code. So you're going to set your key first. Then you're going to parse your disk. So you're going to go through each file. You're going to do the folder. You have to exclude certain folders, because if not, you'll get into a blue screen of hell. You're going to do then you're going to look at the files, and you're going to select the file types you're going to do. Again, if you select the wrong file type in the wrong folder, you could actually potentially brick machines. So the first part really was understand. I mean, if you're getting into this and you don't understand encryption, you need to go back to the basics of understanding encryption. Luckily, I've worked in PKI and I've worked for SCA. So, I mean, encryption I used to do a lot of when I was younger. Now it just hurts my brain because it's math and we have computers to do math. So, who knows what the bottom left-hand one is? The easiest one? It's a Caesar cipher. That's what it's called. I think you were on the right path. But a Caesar cipher essentially was probably the first recorded encryption method, I think, if I remember my history right. Caesar used it to communicate secretly with his general. It's essentially just a tube where you would rotate the letters to decrypt the message or to encrypt the message. That mathematically, that evolved into ROT13. So ROT13 is essentially the same principle that you map letters to other letters, but you shift everything by 13. Then you have XOR. So this is just essentially just applying modulus to your original signal and then just modding it, and so you get a downstream signal. Then you have symmetric key type encryption, which is essentially this is AES, and this gets a little bit more complicated because you have to have an initialization vector, you have to have plain text. When you cipher, you recipher your block, and you keep deciphering your block depending on the type of AES that you're using. Then the top one, which is the more complex one, is, well, between AES and RSA is about the same, but public key, private key encryption, again, as I said earlier, the problem with private key, public key encryption is that you need to set up your keys. You need to generate keys, you need to have a public key, and you need to have a private key. This is technically the safest as long as you know how to manage your keys in terms of ensuring that you don't get reversed encrypted or you get decrypted, mostly because there's nowhere that you have to have that key file, the private key file, to decrypt. Whereas in the other ones, you're storing your method or your key, your secret somewhere inside the code. So I went down the middle. I decided to go XOR. So XOR encryption is essentially the exclusive disjunction operation, right? So again, it's equivalent to doing a modulus 2 additional subtraction. It's essentially the same thing. The logic is that you take a string of text, encrypt it by applying a bitwise XOR operation to every character using a specific key. So if you look at this part here, if this is your text, you apply a key and you get your encryption. And fundamentally, to decrypt the output, you just reverse your operation. So you take your key, apply it to your encrypted text, and you get your original text. Simple enough. And there's plenty of examples of, if you Google math XOR encryption, you'll find plenty of examples of how to do this and plenty of example code. So simple enough. Remember what I said earlier? I'm a lazy bugger. I've got other things to do. And these guys wanted something quick. So then you need to set up a working environment. You're not going to do this on your primary machine. You're not going to do this on your main systems. So suggest VMware or any other type of virtualization solution. You need coding tools, Notepad++, Visual Studio, and one important lesson learned, and I really, really must emphasize that you need to do this. Use the snapshotting in your environment, because otherwise you might actually do this. And if you've made a mistake in your algorithm, you're basically hosed, because you've encrypted all your files and you can't unencrypt. Yeah, it happened to me 3 times. It happened to me again this morning when I was trying to finish my slides. Because you just forget. The problem is, it's like you're sitting on your coding. So I have 2 VMs. I've got a coding VM and I've got a test VM. So I'm sitting on my coding VM and I'm like, oh, okay, I need this piece of code. I need to screenshot this. So I open the file and I open the Word file. and of course everything starts running. So not a good idea. So you need to think about what you're doing. You need to go slowly, do your checks and balances, and make sure that you're doing the right thing, you're hitting the right step. So choose your tools wisely. You need something simple and quick. You're not going to get yourself muddled into, well, who codes with Visual Studio here? Who codes with Eclipse? How many times are you frustrated and just want to throw the damn things out of the door? They're horrible. I mean, all I want to do is code a piece of PHP or a piece of PowerShell. I don't need all these freaking windows all over the place and all this. Every time it takes 10 hours to load. So Notepad++ is a really good tool. Plus it's free. So then you need to select your programming method, right? So I've already excluded C++ and C hash because I just don't want to do anything complicated. PHP is really easy. PowerShell is really easy. Python is easy. There is some constraints though. So depending on the version of the tools that you're using, especially in the scripting domain, you might find that you need more than just your script engine. I ran into this problem with PowerShell. I started with PowerShell because I actually do a lot of PowerShell, both for forensics, both for admin and things like that. And I was testing on one of my VMs, Windows 7 VM, that hadn't been updated in a while, and the PowerShell wouldn't run. And I realized I was actually using a PowerShell function that needed PowerShell 3 or greater. The problem is, by default, PowerShell doesn't really get updated all the time, depending on the OS version. So it limits your target vector. Now, you're going to say, well, you're in a demo, you're just building a demo, who cares? You can control the target vector. Yeah, but I want to understand also the methodology and the thinking behind this. So the problem with PowerShell is you would need a minimal version. So then you need some way to deliver it. We've mentioned it before, attachments, Word or zip. So that's one thing. So then let's plan out the code, right? It's actually quite simple. You set your key, you select the path you want to encrypt. So either you're going to specify, for my demo cases, I just use C user, or you say, well, I know that every drive letter in Windows is labeled A to Z, so I'm just going to pass every drive letter A:\\, and B:\\, and C:\\. So then you start a loop, right? Or a recursive function, depending on how you like to code. But you're going to do a find file, the file types that you want to find. Avoid all the files that you don't want to encrypt. You encrypt the file, you rename the file, and you check if there are more files. If there is, you repeat the process. Once you've finished parsing every folder and subfolder, you just bail out of your code. So how does that actually code into PHP? Well, it looks like this. And you might recognize it. Some of you have actually looked into this a little bit deeper. This is actually very similar to NEMU code, which is one of the variants from last year. So this is PHP. So we got a function, we declare a function, and we just pass our path to that function. Then, oh God, see, I'm a bad developer. I forgot to remove the comments. So this is my key, right? Just to make sure it's not that obvious, I base64 encode it and put it in the script as base64 encoded. But notice my script just says base64 decode. So yeah, how hard is that to figure out? Come on. So then you start to exclude all the folders that you don't want. So like, WinNT, boot, system, Windows, temp folders, program data application, roaming, blah, 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 blah. Just exclude those. And then you start to parse your actual directory until you get to a file. Once you're at a file, you just look at the file extension because you don't want to encrypt everything. You only want to really encrypt Office files. Makes for a better demo. And come on. Once you have that, you open the file, you read a part of it, you open it, and then you read part of it. So here's something interesting. You actually don't need to read the whole file. As long as you read like the first, let's say, byte or 2 bytes, you can create enough damage that the file isn't usable anymore. What you essentially need to do is kill that first part of the file, which is the header of the file, which tells the program that it's a valid file, and that actually starts the formatting of the, starts the part of the data file. So if you think about, recent Office documents, they're all XML based, right? So if you kill that initial part of the file, you're killing the XML headers, or the start of the XML blob, so the file is no longer readable by the Office program. So there's another reason why you do that. Does anybody know why you would want to limit the size of the file you're reading, or how much you're reading of the file? Time. If you read a megabyte file and try to encrypt a megabyte file, it's going to take a lot of time. If you read a very small portion of it, you can execute your script very fast and you can get through all the files in a very short period of time. So, starting to understand better. That's why, when you see some of the guys say, "Oh, I've written this decryptor tool for this variant," either they found the key in the code, or the file is not totally encrypted, so they can actually start to figure out what was missing from the header of the file and start to reverse engineer the key. Once you've done that, you basically change the file name, right? Very simple. This isn't hard. So if you think about it, this isn't hard. Wait a minute. So, now I'm starting to understand better why we see so many variants and why we see so many campaigns. So then you test it. So remember what I said, sometimes you need special versions. So I started with PHP 5. When I started to run it, it started asking me for a whole bunch of DLLs. So the obvious way around this would be to take PHP, compile all the DLLs into the code, but that means opening Visual Studio, doing a full compilation. Oh God, I don't want to do that. So you come down, you go back a version. So it's further back you go, the less DLLs you actually need. You know how we software hogs? It's too much code and too much crap in software. This just proves the theory. So once you've done that, you just test your code right here, and so you see PHP running. You see the files in my test environment are encrypted. So you notice here that. So I've got a PHP executable, I've got a script, so now I need to basically say I've got to put this into a batch script to actually run it, or have some method of running it. So I could do a PowerShell start, pass the parameters in and things like that. But you need to consider that when you're doing something like this. If you're building a single layer application, it just has one executable, it's a lot easier to launch. If you're building a script version, you actually need to think about how are you going to actually launch that script and have all the right files in the right place to be able to launch that script. And that's where you think, are we ready? Well, we need a batch file to run it. We need the executable, the script. Now we need to simulate delivery. And that's where you get into the simplest method, which is a Word file. Or with VB, or in Excel, using DDE. Now, so this is 2 examples of how I, looking at the delivery of my malware. So this is a real. I'll show. There is a demo at the end. So you see the Word document is all funny garbage characters, and up here I put a message. If you need to enable macros to be able to see the text. So there's a whole complex solutions of macros. Now you can do this with set. If you use set, they give you tools to actually build macros like this. You can also find tools on the dark web. This is a really useful tool, but it's Russian. So unless you speak Russian or you have friends that know Russian, you have to figure it out by yourself. Luckily, I have, for some reason, we got a good portion of Russian developers in our company. I have no idea why. They're all based in Boston, don't worry. This is DDE. So I'm sure everybody's heard this DDE attacks, right? It was big. It's been big news for the past 2-3 weeks because Microsoft actually had to release a tech note about it. The thing is, it's like, I've read some of the press and they were like, oh, there's another vulnerability in Excel. It's not a vulnerability. This has been there for years, right? I mean, I know pen testers have been using this method for 5 or 6 years now to not have to use macros. DDE was built into Excel to enable Excel to go and query a database or a third-party tool to gather data and put it into Excel. So it's not a vulnerability, it's not an exploit, it's just the functionality of the program, right? So if you've never seen DDE, this is basically what it is. You do CMD or whatever program, pipe, and then your command that you want to send to CMD. So here I'm just doing PowerShell. Of course, because this is demo purposes, I'm not obfuscating the PowerShell, it's just really simple. So it downloads an executable from the web, puts it in temp, and then starts that executable. And that runs basically when you open Excel, almost immediately. So, wait a minute. You may have noticed in that last slide, I'm actually downloading the executable from somewhere. Oh crap, I need something more. So I had to set up somewhere to put some repository to put my code in to actually download it. So I'm like sitting here, well, I'm not going to use the company web server because then for testing purposes, it wouldn't make it really look nice. Plus the guys would have to be on a VPN. Oh god, it's complicated again. So, and I was looking, we've been moving to AWS. So either you get a VPS, you can get some really cheap ones, or if you're just doing demo, you can get a 1 year small, very small EC2 instance in AWS. It's free. Now all we need to do is register, put credit card, and then after a year, just cancel the account. So for a year, I just had this web server that could download this demo. Hey, we're keeping it simple, keeping it free. So is that enough? Well, I thought to myself, so to be fair, and I mentioned this a little bit earlier, but I'll say it now. I've gotten up to about, let's say, 4 or 5 hours worth of my time just to build the encryptor. I have a valid ransomware right now, right? Because I've got a code that's going to encrypt the disk, and I've put it into a Word document. So if you remember the first parts I actually have a delivery mechanism, and I have an execute for encryption. But one of those execute steps for a lot of ransomwares is actually using exploits and using loaders and using droppers, right? So they use the exploits for 2 reasons. Because there's some of the research I was doing, I actually ran some of these in our environment, and you actually get to see that they're actually using bots and they're using CNCs to actually go further than just encrypting your disk, right? So they're putting a foothold into your environment. So many campaigns do use an exploit to get that foothold and also to control the spread. So then I was going, okay, so we need a loader. Yeah, we need a dropper. Yeah. These are the most common ones. Zeus, DriedX, BiI, Citadel, blah, blah. This was last year, so it was before all the hoo-ha with the CIA exploits and all that crap. And I don't really care about that stuff anyway. Now it's so much public knowledge. But you see a lot of these, right? You see a lot of, if you read some of the analysis from the big companies, Zeus drops malware, DriedX drops ransomware. All of these things are dropping ransomware, the bots and if you were this morning in Josh and Andrea's talk, they were also talking about CNCs bots dropping ransomware. So I set myself out I'm going to put one of these into place just to see how it works, just see how it tests. And I ran into a problem. Who reads Russian here? So this, according to my colleague, it says that you need to basically speak Russian, but more importantly, you need to get an introduction. So to get some of these tools, at least the latest versions, you can't just go onto the dark web and find them and buy them. Well, you're eventually going to have to buy them because it costs Bitcoin. But before you can actually get access, you need to be introduced. It's a very, I won't say tight-knit, but it's a community that actually relies on who you know and who you are. So they will check who you are. They will try to figure out who you are. So I'm lucky enough to happen to have some people who didn't introduce me, but managed to get the stuff for me. So I went with Gaudex. So this is the control panel for Gaudex, a simple HTTP bot. You can install it in any HTTP site, gets installed. So this is like a client ID. This has got a client ID. It tells you the location, the IP address, which Windows version it is, the antivirus, the date it was installed, the date it was last seen, if it's online or offline. You have a map of all your deployments. There's up here, there's a task screen, so you can actually, once you have your endpoints registered, you can actually send out tasks, further tasks. You can set up automated tasks so once they get connected, they automatically get whatever initial tasks you want to run on that system. And you even get a program to generate your payload or to generate your dropper. So really well done. So you get, you set up a profile, you set up your connection with your IP addresses, the path to the CNC environment. You have, you can start up entry name, your mutex, the file name that's going to use, and you have evasion techniques as well, anti-debug, anti-OLE debug, anti-IDA, anti-VirtualBox, anti-VMware, anti-VM general. So it gives you all of these options, and this is an old version. It's a really old version, actually. So once you've done all that, this is what you get. So that's an email I created. So it looks like, you see, there's my encrypted text. So I try to trick users, say, oh, please enable the content so you can see the thing. The stock options grant looks official. Nothing's happened yet. What I've done is I've actually told it to run the payload on close. So there you see the payload, so it just looks like some error happened. So it's injected itself into Explorer, actually. Now, nothing is going to happen for a few minutes. Well, I've considerably sped this up. Does anybody know why nothing would happen for a few minutes? Why I would want to pause all this time? Sandbox. Also, false sense of security for the user, right? Because I've opened this document. Oh, this isn't for me. Normally, you would send it out to phishing, right? But because I've basically done nothing, the user might think, oh, this is an error, right? So, filling blank time. Maybe I should do a song and dance. Oh, plenty of time. It'll come. There we go. So, put a ransomware note up. So I just put gibberish. I copy-pasted a bunch of ransomware notes because I was lazy again. There's my encrypted disk or drive. So very simple. So total time to get to that demo was probably about 3 days because I had to argue back and forth with the people that I know to get the actual exploit part. So it's not hard. It really isn't hard. So when you think about all those campaigns, well, that's one of the reasons why we're seeing all these campaigns. It's simple enough, right? I mean, anybody can really do it. There are GitHub repositories from researchers as well that have ransomware scripts in them. Python, I saw one last night, Python ransomware script in GitHub. The real challenge is to introduce an exploit and some advanced techniques. There was reasons why I introduced that. I wanted to have that exploit part. Total time to encryption was less than 24 hours, right? So if you think about that, then you think about last year, 38% of companies paid ransomware, paid to decrypt, okay? But what was more interesting is we actually recently found out that 59% of employees paid it out of their own pockets and didn't tell their employer. So if you were at the Jess's keynote yesterday, remember she said we have to enable the user to make him, to give him incentive to report and to tell us? Well, obviously we're doing something wrong because if 59% of users paying it out of their own pocket, we're not giving them the effort, or we're telling them it's bad and they're getting into trouble if they report it, right? So for a malicious attacker, it's all benefit, right? There's very little effort, return on investment is incredible. And you kind of, I mean, we hear the press and they say that as well, but once you've actually broken it down and you've done it yourself, you kind of start to realize, yeah, it is really good return on investment. So then how do these guys get past, your typical prophylactics? So AVs, next gen protection. Well, you notice I use scripting methods, right? Number one, the scripting engine, PHP, Python, PowerShell, I said it earlier, are all flag green, even with next gen endpoint protection. They don't check scripts by default. That's the key word, by default. So the problem that I saw, and I did run this against that green logo. In that green logo, there's an option that says, only do executables, or don't do. You have to check, validate scripts as well. The reason vendors do this is because if you think about sysadmins, right? They're running scripts all day on the endpoints in the big corporation. They're using scripting technology to manage systems. So by default, these solutions don't look at scripts, right? So they don't look at that JavaScript being launched from the zip file. They don't look at the Python script that's being run to encrypt the disk until you turn it on. It's only when you introduce exploits that you get detected, or do you? If you do pen testing, and if you know your stuff, you know that you can actually vary your payload in many different ways. So introduce variety, introduce different techniques, so you can actually fool the endpoint protection. What about more advanced techniques? So how do you evade things like end-user endpoint behavior analytics? So we're starting to see that being introduced in next-gen endpoints, where they're looking at a process that's touching multiple files in a very short period of time, right? And a lot of files in a very short period of time. Easy. Introduce latency into your loop. Encrypt slowly. They also look at, is this really a process that's running in the right context? Well, since I've already exploited with my dropper Explorer, why don't I just run it in Explorer, right? Or run it under Explorer. That bypasses that. I've seen some of the solutions use file name extensions to detect or ransomware note dropping to flag or generate an alert that this is a ransomware. Easy enough. Just randomize the extension. All I have to do in my script is add a randomization loop into my extension name, create a random extension name, and So I was going to go into evolutions, and I was actually going to try and do some evolutions for this talk, but then this happened. I got pwned by that flurry fluff ball. Horrible cat. So maybe that'll be a talk for next time. So we're right in time, aren't we? Yeah. So that's the talk. Do you have any questions?
Well, thank you first of all.
Thank you.
Thank you very much. When you randomize file names while encrypting, and if you're a concerned malware actor and want to decrypt the files, then you have to have some kind of way to find out whether this is one of your encrypted files or not. So just randomizing the file names, I think, would result in something that you can't decrypt any longer.
Yeah, you only randomize the extension name. But if you remember my code, right, or that code snippet. Let me go back to the code. So I'm renaming down here, right? So I have a static crypted string. All I have to do is up here before I start my tree function is create a global variable with a randomized name, and I only have one name, right? Or I pass it as a function, part of the function. The thing is, there's a part that I don't have in here, which is my batch file. I didn't want to show that because there's some other stuff I do in it, and that could be future talk. But in the batch file, I actually set registry keys. to say if you double click on this encrypted, run preview with this JPEG, right? So it does get complicated to randomize the file extension name, but you can do it. And I did do it. I'll be honest. I did do it because I'm having an argument with somebody in my own company. Any other questions?
So I see that's the responsibility of the company to teach the people that they tell it to the IT sysadmins that it happened, instead to hide it and pay it themselves.
Well, it's fear, right? And Jess talked about it yesterday morning in the keynote. It's like if you breed a culture of fear in your own company, it's like, oh, ransomware is bad. If you do ransomware, you're going to get into trouble and all this. People are going to avoid it, right? Or it might be the guy that's at home with his laptop, gets his files encrypted, doesn't have time to go back to call IT or go back to IT to get it fixed. So he just wants to carry on working. So he pays the fine, he pays the bitcoins and decrypts his files. The problem I don't know if it was in that slide or if it's on my other data that I have, but they've actually, out of the 39% of companies that paid to decrypt, I think it was only 75% actually got their files back, right? I mean, WannaCry, right? Think about WannaCry. The initial WannaCry, there was just a Bitcoin address that you needed to pay to, right? But there was no way for you to get the decryptor.
But yeah, I see it's for me it's like a homework for the IT staff of the company to destroy this fear and tell the people.
Yeah, we need better methods. We need to restore confidence, right? Because the stats from last year, phishing campaigns were doing their job, right? And they were doing their job well because if it wasn't working, you wouldn't see that growth in attacks. There's another question right here. Right.
Only wanted to comment your topic that only part of the ones who paid got back their files. This is breaking the business model anyhow, yeah. So they are not interested on only encrypting, and because then the message is spread that it doesn't work anyhow when you pay. So
Yeah.
and we had some other cases previously when there was. For instance, spam with Viagra and so on, and the first tablets they sent out was only blue pills, yeah? So the people recognize that doesn't work, and so you are not gonna buy this stuff anymore. And the same is here, yeah? So they want that it works, and we have also seen cases where they use then the Bitcoin protocol as such to send back the key to decrypt the information again.
Right. I mean, they need the effective ones are the ones that do the full chain, right? So I worked with a lot of hospitals last year in the US, and if you remember last year, at the beginning of the year, hospitals were being targeted like crazy in the US. And I actually talked to one hospital. It was the third time that they had been hit, and they were going to pay a third time. And well, number one, you just start to think it's like, what the hell is IT doing in that hospital? And number two, these guys have a really good, return model because they know that these guys are paying. They can keep targeting these guys and keep getting money out of them, right, until they stop paying. And for me, that's a really interesting model long term, right? Is if you have that capability of, return customer, right? It's like Amazon, it's like the return customer thing. It's like you pay this first time, you get 10% discount, right? And the second time, you get 20% discount. Third time, you get 40% discount. Yeah, it's just. No, that breaks the model.
Right, last questions.
There was one more question.
Yeah, quick question. Have you observed ransomware on mobile phones?
It is possible. There is existing demonstratable, but it's mostly Android and, you know, unlocked phones and stuff like that. But that's there's two problems with that, right? So I deal more with corporates. I don't really deal with the end. I deal less. I don't deal with consumer. So I deal more with corporates. I have a simple answer for corporates, and you know, fear that. It's like your mobile park should be managed via an MAM, right, or an MDM. So you can control what's going on and what's happening on the endpoint, on that endpoint, and you can sandbox all the applications and et cetera, et cetera. If the only ones that I know of, and I don't know all of them, right, but the only ones that I know of affected rooted phones, right, or phones that weren't running stock systems, or because the user had disabled the check signature on app, before running APK or whatever, right? So yeah, it is possible, and I saw, who was it that did prediction for 2018? This week, they sent out a prediction for 2018 that Android-based ransomware was going to be next year's ransomware big hit. You're thinking corporate. You're thinking a corporate user. You're not thinking a consumer. If the yeah, but I mean, well, if you get it on Apple, you're a freaking genius. If you get it on iOS, but on Android, most users don't have that, right? They don't link their Android device to Google Cloud. They don't sync the device. The Samsung OSs, they're old. Depending on the model you have old OS, so it's not up to date, so it doesn't have some of the features. And consumers, they store everything on the device nowadays. I mean, some people, it's their only device, right?
But